Welcome, everybody, and thank you for joining the first installment of our new Geomagic Design X product spotlight series. This webinar is focused on the Helix sketch functionality in Geomagic Design X. I appreciate you joining us today, and I hope you are able to join us again on future product spotlight webinars. And I will now pass it on to Tobias Klein, a Geomagic support specialist, as he is leading today's demonstration. Tobias, it's all yours.
Thanks, Ralph, and hello everybody. Today we want to have a closer look at the helix and its different occurrences and shapes, and I will show a possible approach how to reverse model a helical feature in Design X using a sweep. Helixes are quite recognizable in most parts, but sometimes you may only see a small part of it. There are two types of helixes, a constant helix and a variable helix. Common applications for helixes are augers, screws, threads or drills, but there are also some more complex applications like springs, which often have a variable pitch or radius, or barrel cams, as their helical shape can be quite complex and is mostly only partially visible. Even some decorations may have helical shapes. Some words about the terminology we use in Design X. Each helix has a starting point and a vector or axis it follows, as well as a certain number of revolutions along a total height. Helixes can vary in their pitch, which is the spacing between the revolutions, and the radius, which is the distance between each point along the helix and its axis. Here are some examples of constant and variable helixes. On the top left you can see the constant helix. On the top right is a helix with a variable pitch. On the bottom left is one with a variable radius. And on the bottom right uses a combination of the two variables. The angle between the axis and the parameter of a helix curve can change between 0 degrees, where the radius is constant, and a value near 90 degrees, while the radius increases and the pitch decreases to a value near 0. As soon as the angle reaches exactly 90 degrees, the helical pitch is 0, and the feature is now called a spiral instead. The radius change along the spiral is called the spiral pitch. The spiral curve is another feature in Design X. In the software demonstration, we want to have a look at how to create a thread of this jar cap using a sweep feature. In order to create the sweep, we need to extract a close profile of the thread tooth with a few dimensions, which I already did using a mesh sketch. When creating this mesh, we have to make sure that the sketch plane cuts through at least two of the teeth of the thread, because we need the distance between them later for the extraction of the pitch. Next, we can extract the sweep path using the Helix Curve. It can either be accessed via the menu, Insert, Modeling Feature, Helix Curve, or in case you use it more often, you can right-click on the ribbon and select Customize Ribbon to place it here inside the ribbon for faster access. I already did that, so I can use it from here. When the dialog opens up, we can select first the method between constant and variable helix, and then we can choose an axis and a starting point. As axis, we can select each line type or revolution type face or object. So I can basically select sketch lines or also vectors, or I can also select a circular edge like this, or a cylinder face or a conical face. In this case I will select this cylindrical face. For the starting point we can select any point type feature. So in this case I will select the sketch point here. When we look in this profile view, we can see the flow of the helix from 0 to maximum height. And I can plot the mesh section as a guide curve, similar to the mesh sketch. We have a pink line here. And here we can estimate the pitch and the total length and the radius change. In this case, the angle is 0, the radius is constant, and we can estimate the height. The value which is in here is a little bit longer, so I can edit it by clicking in this input field. And the other value is highlighted in red, so it indicates that this value will change when I change this value. So I change this value to 9 millimeter, and the number of revolution changes to 1.8. As well with the pitch, it's currently 5 millimeter, and it needs to be slightly bigger, so I change it to 6.25. And the number of revolution changes again. So looking at the helix, we can also select whether we want to go counterclockwise or clockwise, looking from the arrow tip towards the starting point of the helix. So in this case, this is counterclockwise. And we can select whether we want to extend the helix in the opposite direction and about how much, in this case, the number of revolutions. I will enter 0.05 here. So after the helix and the profile sketch is complete, we can select the solid sweep function. In the solid sweep function, we can select our profile sketch and our path. And we need to make sure that the result operator is neither cut nor merge. So we uncheck both because we want to edit the ends of the thread. I already created planes which are rotated about a certain angle in the beginning and the end. So we can split the thread at that plane position using the intersection mode. Split face, intersection using the tool, the plane as tool entity and the thread flanks as a target. The same thing happens at the end using split face, intersection. The plane is the tool and the thread flanks as target entities. And finally, we can use a draft to slim down the ends a little bit into the wall. So we can select the neutral plane, which is this plane, and the draft faces. And then enter a 1 degree fillet, 1 degree draft, and the arrow tip points into the direction of the slimming. So in this direction. Same happens for this side. Neutral plane is the split plane and the draft faces. And then the arrow tip points into the slimming direction. So finally we can check the deviation. And within 0.2 millimeter, we are inside the tolerance. At the last step, we can merge the thread into the cap. And that concludes the live demo. Thank you.